You see these, Ray? You see these? Those are heads. See? That's for an LS. That's for a small block Chevy. That's for a small block Ford. And this is also for small block Chevy. This is what Daddy runs.
Oh.
Yeah. Do you want to see Daddy help make people go fast?
Yeah.
Okay, well that's what we're going to do in today's video, okay? We're going to go over the different types of motors that you can run and why the head choice dictates what motor we want to run.
Oh.
Yeah, isn't that cool?
Yeah.
That's awesome, isn't it? I didn't realize how much this would help people. So we're gonna go over some more engine tech today, why I personally chose the small block Chevy for my engine platform, and what other options are, and what's the pros and cons of each one. The only thing that I don't have here is big block Chevy as an option, but I can go over small block Ford, small block Chevy, and LS, and I think that that will, my son's playing music for us in the background. I hope you guys enjoy that with his little car. But anyway, we're gonna go over some stuff on why I chose the small block Chevy. And if you'll come on in here, you'll see that this is your standard small block Chevy head. All right, and I've drawn a circle to simulate what the bore would be with a 4" 30 bore. Okay, Ray. So this is a 4" 30 bore, okay? This chamber was actually designed for a 4/125 bore, but just to keep everything simplified, we're gonna use a 4" 30 bore as our standard for this bore spacing and the size of everything, okay? And you can see that this is an exact 4" 30 bore on the inside. This is actually how I install my piston rings. So we'll start with the small block Chevy here. You'll notice that I've circled each bolt hole, head bolt hole. So the Chevy has 5 per cylinder. 1, 2, 3, 4, 5. Okay? Now we're gonna come up here to the LS. It's got 1, 2. This is optional if you have an aftermarket block. We're not gonna count that right now, okay? We're gonna say 3, 4 around the ring. It has these 2 up here that just help clamp for the oil not to pass through, but that's not really clamping the cylinder pressure. So we're just gonna call this a 4 head bolt per cylinder head, unless you have an aftermarket block and you can add this to it. Okay, then we're gonna move over to the small block Ford. Same thing as the LS, 1, 2, 3, 4 head bolts per cylinder. All right, now why is that important? Well, when you run power adders, you run nitrous, you run supercharger, you run turbos, you're getting an unbelievable amount of cylinder pressure that this head gasket has to seal. You'll notice that if you have this simulating the bore, how close my 5 head bolts are to the cylinder. You see that? They're just on the outside of each one. So that's very close. If you lay it on the small block Ford, they're pretty far away from it compared to the small block Chevy. You notice that? Okay. Same thing with the LS. Look at the distance to the bolt holes from the center of the bore. So these are much tighter. So they're going to handle more cylinder pressure without allowing that gasket to blow out. Now, that is one of the main reasons I chose the small block Chevy. Can you make the small block Ford or can you make the LS handle major cylinder pressure? Absolutely. Is it a little harder? Yes, it is. Would I rather start on easy street? Absolutely, I would. So that's why I chose that. Now, that is just one of the reasons why I particularly chose the small block Chevy. Other reasons are I had a ton of it laying around from my dad. Cost. I think that it is by far the cheapest in cost based on what I've been able to price for other platforms. All right, so what's negative about this small block Chevy and what could allow a head gasket to leak is the fact that it has a coolant passage right here next to this bolt hole. It also has one here. It has an oil drain back hole here, water here, and water here. So from this head bolt hole to this head bolt hole, this area right here would be bad about leaking, and this area here would be bad about leaking. It would be really nice, and some people have been able to do it, to add a head bolt here where the dowel pin is on the small block Chevy, and it will handle a lot more cylinder pressure that way. That brings us to my head that I run. If you'll notice, I've welded up all of the water coolant passages. So all that's left is the head bolt holes. And you can see exactly where my bore is with this stainless steel hoop. Yeah, I saw it. So this area I welded up. This area is welded up. This area, there's areas here. I can't find all of them. I'm not sure if that was one or not. This is definitely a big one here. All of these areas I welded up. Why did I do that? So that the deck of the head couldn't flex as much in between head bolt holes. So the likelihood of this head bolt hole and this head bolt hole allowing this area to flex is higher when this deck is not solid right here after I've welded it up. Now, how am I able to weld those up and not let my motor overheat? Well, what I do is the same thing to my block. I weld up all the coolant passages in the top of the block, and then I just run water through my heads. I don't run it through my block, because when you run methanol, it cools the motor so well, you can get away with that. But on a nitrous engine where you're running gas, you can't really get away with this unless you run coolant through the heads individually and the block individually. And I would say that that's a major advantage to running a boosted methanol combination. All right, let's talk about bore spacing. The LS and the small block Chevy stuff is on a 4.4 inch bore space. What does that mean? That means that the center line, let's just call this the cylinder that the head is clamped down to on this LS. The center line of it is 4.4 inches to the center line of the next cylinder, right? And then 4.4 inches to the next one, okay? The small block Ford is 4.38. So from the center of that to the center of this is 4.38 inches, okay? Almost identical, not much difference. What does that control? Well, that controls our bore size that we can run. Bore size is critical. Why does that control our bore size? Because if you'll notice here, my two hoops are very, very close together where they actually seal the head gasket. Can you see that well? Okay.
Quite well.
So if I go much bigger in bore, I run out of room for sealing, and my cylinder walls get really thin in between these two cylinders. Okay, you don't want to do that, because then your cylinder walls start flexing around. You can't seal your head gasket. It causes a lot of issues. So on my boosted stuff with a 4.4 bore spacing, I try to stay at 4.125 bore max. I mean, if I have to go to 4.130, I'll do that. I try not to get up to 4.155 or larger. I just really want that cylinder wall thickness. I could make up for the power that I would gain in going with a bigger bore with my cylinder walls being a little thicker and not flexing around as much. Just add a little boost, add a little timing, and be better off that way with a more reliable combination. Alright, so let's move on to other reasons why we choose different heads for different engine platforms. So right here we have the small block Ford. Right here we have a regular small block Chevy. Both of these are aftermarket, standard valve angle, run-of-the-mill heads. Right here is a raised runner small block Chevy. This is an LS3, and this is the head that I run on my motor, which is a 13 degree. Okay? Now, you'll notice that this is what I would call the deck surface of the head, right? Alright, so how high is the runner from the roof and the floor off of the deck on a Ford? Small block Ford, on a standard small block Chevy, on a raised runner small block Chevy, and you have to get in the fact that this is the deck down here, so this has been cut out for lightning, because this is an aftermarket raised runner head with 23 degree valve angle. That's my microphone. Hang on, let Daddy talk. Look at the distance of it on the LS motor. Look at how much higher our port is. Okay? Now look at it on my motor, my 13 degree head motor. Now, you're sitting there thinking, now, why is the LS in my head so much higher? Here's the reason why. On a small block Ford, the air's got to come in here real close to the bore, because the bore is here, the deck is here, and it's got to come in here and it's got to turn this sharp edge. Same thing with our regular small block Chevy. If you notice, it actually ramps up in there a little bit, right? So that it can help it make that turn. Make sense? All right. Now, on the LS3, if you look at it, it's much taller. The curve, the short side radius is. Same thing with my head. My 13 degree, it's much taller. It can go in there and make that curve more gradual. Why does that matter? Because we're trying to flow as much area around the valve as possible. So if you notice when I put a valve in here, okay, that's what's blocking your port. The valve is. If we had a way to have a shutter, like a flat edge, that would just come in here and slide across, like let's call this an internal valve, and it would just open and close the hole, you know, something like an F1 head design, then you would have nothing blocking the hole. You could flow a massive amount of air. But we can't do that. So how do we fix that? We raise our ports up. And when we raise our port up, see my crude drawing here, the air, this is the air here, can make this corner and flow out this side of the valve, and not just all of it flow out where my arrow is here. Like if this was a short turn like this one, most of the air that tries to make this curve hits on top of the valve, and that's bad. Most of the air that comes through a standard small block Chevy or small block Ford port flows out this side. Okay, it can't really get out here, so you're not really effectively using your 360 degrees of your valve opening hole to get the air in and fill the cylinder. So my baby's not feeling too good, and Mama's gone shopping on Black Friday, so Daddy's just kind of loving on him while we're going over this video. We're going to discuss bore space, or bore size, the diameter of our bore. So I've got a 4" 30 bore replica piece laid over this combustion chamber of this regular small block Chevy head. And if you'll notice with my valve open, between the bore and the valve over here, there's not very much room. So we're not gaining flow on this part of the port very much at all. You're not getting but maybe 80% of the valve can actually has room for the air to flow out. Okay, so if you go to a bigger bore, like a 4125 from a 4130, it opens that area up, because you can come in here and you can open the chamber up right here to match your bore size, and it allows more air to flow out this side of the valve too. So you're using more of a percentage of your valve. You're getting closer to using 360 degrees of it. So one thing that people don't discuss is the center line of the bore. So your bore can be moved up here and your bore can be moved down here. That's an exaggeration, but you're trying to get your valve centered in the center of the bore. How can you control that? Well, do you see this dowel pin right here in my head? My dad used to cut those in half and weld them to where it offset them, and it moved the valves closer to the center of the bore to unshroud them more. So one more quick thing I want to go over is the thickness of the deck of your head design. So how thick this material is on this entire flat surface is very important, because if it's flexing any under that massive cylinder pressure load, it will also allow a head gasket to blow. And that's something that you want to stay away from. And every head design has a little bit different thickness on that deck, and you want to kind of do a little research on that if you plan to push it to the max. The last detail I want to go over on your cylinder head choice, the Ford and the LS have equal spacing exhaust ports, if you'll notice. None of them are close together. On your standard small block Chevy, they're very, very close together. On my aftermarket small block Chevy, they're spread apart a little more, okay? The reason why this is important is because this is the hottest spot in the entire cylinder head. Can you see this head in the picture? Okay, so when you spread these exhaust ports apart from each other, you don't have one hot spot that you're fighting in the head, okay? So what I did to combat that with mine, not only does it have them spread apart just a little bit more, I'm pumping my coolant in between the two exhaust ports, so I'm getting that cooled faster than any spot in the motor. That will be the conclusion of the head tech video on where I'm giving you all of the information on the different head options. As far as moving forward with why that is so important for each combination is your head really makes or breaks you in how much power you're capable of making, especially if you're doing something naturally aspirated or on nitrous. As far as being a boosted motor, you can get away with a lesser flowing, lesser design head by adding boost and having a head that has a thick surface and can clamp that head to the deck strong enough to not allowing the head gasket to ever blow. That's very important. So you could put just more boost, make more power, and your head design is not as critical in if the ports are the max potential for flowing air. It's more about just harnessing all of that compression. So in the future, we're going to go over different choices of motors for other reasons, but we thought that what motor you choose really needs to start with the head and the ability to hold the compression in the cylinder. That's the most important thing. The next things we're going to go over with motor tech when it comes back to a video on which platform to choose will be weight of the entire assembly, and we're going to try to get a lot of different types of motors on the scales and show you the different weights of them. And it will also be cost. Maybe we can do some cost comparisons and a few other things that kind of give you an idea if you're looking at getting into this, which one might be best suited for you. And we really appreciate you guys more than you know for watching, tuning in. Please like and subscribe our stuff. Please comment. Help us move forward so that we can do more for you guys. We're willing to share, and we really appreciate you. That was a good race, Ray.
I didn't hit that mud.
Yeah,
I didn't hit it.
that was a good race.